Good morning, dear students. I am Miss Naveda Shaikh from Brahan Mumbai Mahanagar Palika MCGM virtual class. I welcome all my dear students to another and interesting session. In today's session, we'll be learning something new and interesting from a science textbook. So let's get started. Good morning, students. I am Miss Naveda Shaikh. Welcome all my dear students to another and interesting session. Today we'll be learning about laws of motion in your science textbook, and this is a lesson for my 9th standard students. This is related to physics. Okay, now everybody thinks that physics is quite boring, but it is not. And let us prove everybody wrong by learning this chapter. Before we move on to laws of motion, there are a few examples here on the screen. This boy is playing with a ball, right? Means the ball is moving. Next, here the trains are at halt. They are not moving. In the next one, you can see the children are swinging on the swing. They are moving to and fro. This bird is also moving, right? So from out of all these images that we see, only the train is something where you do not see anything, any movement taking place. Okay, rest all the things are moving with respect to the surrounding and their position are changing. Okay. Okay, so here you can see the solar system where you can see the planets also moving. So here this example also tells us that how even in the solar system motion is taking place within the planets also, right? So if I ask you to give me few more examples of motion, you can give me a list of thousands of it, right? So now in order to move something, to set something in motion, you need to either push it so that the object moves, or you either pull it, like this image where the kids are playing tug of war. Okay, they're exerting some force onto the rope and they're trying to pull each other, right? So a person needs to put in effort to set something in motion so that the position of the object changes. Okay. So your motion of an object, you can see this boy walking, and as you can see he is walking, there is motion taking place and the position of this boy is changing with respect to the surrounding. That means he is moving at a particular interval of time. So we can say that his body is set in motion, right? This another example that you see here is a ice cream truck. Now, when you are standing outside and looking at this truck, ice cream truck, you will see that the truck is moving. But a person who is sitting inside the truck feels that the trees, the people outside, they are moving. They feel that way, okay? It is not actually happening, but they feel like that. So that is why we say that motion is a relative concept. If the position of an object is changing, okay, if it is changing with respect to the surrounding, then it is said that the object is in motion, and if it is not, then we say that the object is at rest. Like in the previous slide that we had seen where the trains were at halt, means they were at rest because they were not moving. Their surrounding, their position was not changing with respect to the surrounding. Okay. Last year, we also learned different types of motions like rectilinear motion, periodic motion, oscillatory motion, circulatory motion, translatory motion, curvilinear motion. Okay, so these are a few examples of what we learned last year. The very important topic is displacement and distance. Displacement and distance are two things which go hand in hand, and you need to learn it that way to make it, to remember it for a longer period of time. Now here you can see your house and your school, okay, and there is this route that you need to take to reach your school from your house. Now the length that you travel from your house towards the school is called as the distance you have traveled, okay, whereas the smallest or minimum amount of movement that you have taken, that is the change in position from the starting point to the end point, is called as the displacement. Means how much your body has moved. Your body has moved from school to the home. Okay, that is the displacement. But how much length did you walk in order to change your position is known as the distance. Okay. Okay, so here in this picture, there are 2 points, and the length between the 2 points that has been covered is known as the distance. Now, if I have to travel from town A to town B, and there is a road where construction is going on, and I have to take a longer route, which because of which my distance has increased, right? And after the work has been completed, the distance that we covered will be measured in terms of meters. Okay, the unit is meters with a small m. Now the distance that we covered was earlier was 20,000 meters, whereas because of the work going on, we had to travel 50,000 meters. But we do not like such huge numbers, so we will convert it into kilometers. So 1 kilometer is 1,000 meters. So we had to travel 20 kilometers, but we traveled how much? We completed 50 kilometers. So with this, do you know whether distance is a scalar or a vector quantity? Here we do not know that we travel 20 kilometers in which direction, right? It could be any direction. So here this 20-kilometer direction has not been specified. It could be anywhere. So that is the reason distance is a scalar quantity. Which brings us to displacement. Displacement means distance with direction. Now again with the same example that we traveled from town A to town B, from the long route that we had taken, that was 50 kilometers, the time required was more as compared to the smaller route, right? The time required for completing 50 kilometers was more, and we moved towards the north direction. Now here we are mentioning that we moved 20 kilometers north from the home. Okay, and here distance is measured 20 kilometers, and we also know the direction, and hence here direction is specified, and that is the reason displacement becomes a vector quantity. So displacement is a combination where you have distance and direction given to you both. Okay, and with which you understand that displacement is a vector quantity. These are a few things that you need to remember. What is a scalar quantity and what is a vector quantity? Again, I will revise because we'll be using these terms again and again. So there need to be clear idea about these two things. Scalar quantity means any physical quantity which has magnitude only. Okay, means how much it has traveled. It is not going to tell you in which direction, north, south. Okay, so your only magnitude. Magnitude means how much it has traveled. how much length it has or distance it has covered. Okay, so those are called as scalar quantities. Whereas when we talk about vector quantity, you will be having magnitude and direction mentioned both. Okay, so hence we learned right now displacement is a vector quantity and distance is a scalar quantity. Here in this image, you can see two boys are doing car race, right? So it is related to motion. They are moving, both the vehicles are moving, but at a particular rate. We do not know which one is moving fast or slow. Now, if you want to know whether it is moving faster or slower, we need to understand how much time are they require. They require to complete that particular distance, right? So this next topic is very interesting, that is speed. So let's understand what is speed and what are the things which are important for us to know in order to calculate speed. This image. Now there are two balls which are moving and how will we come to know whether which one is moving faster, right? So here is an image of two, there are two objects, object 1 and object 2. You have to look and observe which one is moving faster. Okay, now if you notice object 1 is moving faster and object 2 lags behind, right? And because of which we come to know that the speed of object 1 is greater and the speed of object 2 is lesser. Okay, so this speed is something which tells us how fast something is moving. Okay, now speed, as I told you, it helps us to understand how fast things move. So to find out speed, you need to know the distance and time required. Okay, so how much distance this car is traveling and how much time does it take. Now, if you notice, the car is moving in a straight line. That is a rectilinear motion. The time taken to cover is 30 seconds, whereas the red car, which is here, is moving along the same straight line. Okay, but the time taken by this car is 40 seconds. Okay, so there is a difference in time which will help us understand. Now the distance is the same for both the vehicles. So we need to know whether which car has covered, had a greater speed. Okay, so obviously time required less was by the blue car and hence the speed of blue car was much more. Let us assume that the path length was 420 meters for both the cars and the time taken is different. So if we will calculate the total distance upon total time taken, it will give you the speed of the cars. Okay, so as you know that the speed of the red car is 10.5 meter per second and for blue it is 40 meter per second. So we come to know that the speed of the blue car is much greater. Okay, understood? Now with this I hope you all have understood how you can find out the speed also and what are the things required to find the speed of a given object. Okay. The next thing that we'll be learning is velocity. When you see this car, again, here we have a car moving. In order to have complete information about the movement of a body, you must know that only the speed of the body but also its direction. You should know both the things. How it is moving and where it is moving. The physical property which gives us both the speed and the direction of the body is called the velocity. Okay, previously we just learned that the vehicle was moving, but here in velocity, the moving body is the velocity is what? The moving body is the rate of change of the position of the body with time in a particular direction. Direction is important. So velocity has both magnitude and direction. The magnitude of the velocity gives the speed of the body. Okay. If the car is moving from west to east with a speed of 60 kilometers per hour, then we say that the velocity of the car is 60 kilometers per hour due east. We mention the direction as well. Okay. So velocity is also clear. Again, I'll repeat. Velocity is related to speed and direction both. Okay. Whereas speed is only related to distance and time. Here you need three things: distance, time, and direction. Another example here which helps us to understand the relationship between speed and velocity. Now here I have two houses. There are two roads. Road 1 which is 30 kilometers and road 2 which is 18 kilometers south. Okay. So if you notice there is an extra south mentioned here. So if this car is moving from road 1 that is 30 kilometers and the time taken was 5 hours, and if I have another car which takes 2 hours to complete and move towards south on road 2, this helps to us to understand the speed and velocity. Okay, the green car will help us understand speed. Speed is equal to distance upon time, that is 30 kilometers upon 5 hours, which is 6 kilometers per hour. Whereas velocity is 18 kilometers towards south and time is 2 hours. And if we calculate it, we get 9 kilometers per hour due south. So velocity is nothing but speed plus direction. Okay. Same formula that we used for speed was the distance upon time plus direction also. Okay. That helps us to find out velocity. I hope clear to all my students. So there are a few things that we'll just quickly revise with speed and velocity. What is the term? What is meant by the term speed? Speed is how fast you are going with no regards to the direction. How much distance you have traveled within lesser time. Okay, how fast the vehicle was moving. That is speed without knowing the direction. We are not concerned with direction in speed. Whereas if we talk about velocity, you must have the direction specified as well as the speed. So the unit of speed and velocity is meter per second, and in CJ system it is centimeter per second. Next, speed is related to distance while velocity is related to displacement. If the motion is along a straight line, the value of speed and velocity are the same. Otherwise, they can be different. And velocity is the displacement that occurs in unit time. Okay, displacement I've explained you all earlier. I like that word. Next is the distance traveled in a particular direction by an object in unit time is called its velocity. Okay, this is a proper statement that you'll need to know for velocity. The distance traveled by a vehicle or any object in a particular direction by an object in unit time is called velocity. Your unit time could be 1 second, 1 minute, 1 hour, etc. The largest unit could be 1 hour also for unit time. Okay, so the displacement that occurs in unit time is called velocity. Okay, so for speed, distance is important, and how fast the object is moving is important, whereas for velocity, displacement is required in unit time. Okay, and you need to know the direction as well. Stop here, and we'll be continuing with the remaining part in the next coming period. I hope you all enjoyed this session. Thank you.
If you liked our video, please subscribe to our channel and do not forget to hit the like button.
Hope this session was quite useful to you. In the next coming period, we'll learn something new and interesting. Till then, thank you.